My name is Jace Bernhardt. I'm a graduate student in the Department of Geography at Penn State University. And this poster summarizes my research done for my master's thesis while at Penn State in geography. This involves looking at jet contrail outbreaks and specifically their impacts on surface temperatures, in particular the DTR or diurnal temperature range, difference between maximum and minimum temperature, and then the conditions favorable for forming these particular jet contrail outbreaks. So jet contrails form due to jet planes flying high up in the atmosphere and releasing water droplets and other chemicals, and when there's enough ambient moisture at that level of the atmosphere, they can freeze into clouds and form these long, narrow, linear-shaped clouds. These are known as jet contrails. So when you have several of them forming at once, due to many planes flying over in favorable conditions, you have a jet contrail outbreak forming, and if there are many of these clouds, and if they last for a few to several hours, you can see impacts on the surface temperature. Now the opposite of the study was done in the days following the September 11th attacks, when you had the grounding of all commercial air traffic over the United States. You saw in the absence of jet contrails an increased diurnal temperature range or DTR over places like the Midwest that saw lots of planes normally flying over them. However, in places like the Midwest, where you have several outbreaks, you normally see a suppression of the DTR or diurnal temperature range due to jet contrail outbreaks. That's simply because during the day, the jet contrails reflect away incoming solar radiation, leading to a slight decrease in the maximum temperature. And at night, the opposite occurs with the temperature increasing slightly because escaping solar radiation is trapped by the additional cloudiness and bounced back down to the surface, rewarming it a little bit or slowing that cooling effect. So to test this theory that underneath the jet contrail outbreak we see a suppression of DTR, that difference between high and low temperature on a given day, compared to sets of weather stations, one seeing the jet contrails overhead and one's nearby with similar conditions except that they were not seeing the jet contrails. And this was done based on a reanalysis of satellite data which showed where the jet contrail outbreaks were occurring based on seeing those long, narrow clouds showing up in the satellite imagery. So in comparing the stations seeing the outbreaks versus nearby stations not seeing the outbreaks, we saw a statistically significant suppression of the diurnal temperature range in weather stations inside the box or seeing the contrails overhead. It's about 5 to 6 degrees Fahrenheit. And further reinforcing this, the same data for jet contrails is the fact that in the non-outbreak stations, so stations just seeing the normal conditions, you had a positive anomaly of DTR or a larger DTR than average. But inside the contrail outbreaks, we had a smaller than normal DTR. So that's kind of showing that the jet contrails on this small scale are more important than the larger scale pattern. Larger scale pattern would lead to higher than normal DTRs because you're seeing clear, mostly clear skies otherwise. With those jet contrails, the increased cloudiness is leading to a suppression of the DTR. That's sort of one really important and interesting result of this study.